All right, so let's do another one. Moss is growing at the base of a window frame. Under intense light, the area of the rectangular region of moss grows at a constant rate of 2 square inches per day. So they just gave me a rate of change right there. The width of the rectangular region of moss is always 1.5 inches. The width is always 1.5 inches. It's constant. It's not changing over time. With respect to, I'll write over this time. It's not changing over time. Now we're being asked to go ahead and find a rate of change, find the rate at which the length of the rectangular region of moss changes at a particular moment in time when the moss is 5 inches long. So I'm going to go ahead and draw a diagram here first. So we've got a rectangular This is the base of my window frame. All right, so that's the base of my window frame, and we've got some moss growing, green, some moss growing in a rectangular region. That's my moss. And they told us that the width is always 1.5 inches. This is always 1.5 inches. And we've been asked to find out about the rate at which the length of the rectangular region of moss is changing. So here's this length. And since the moss is growing, that length is getting longer and longer. Its rate of change is positive because it's increasing. We can also draw this. You don't have to draw 3D. It's fun, but here's my moss. There's its area. We can fill this in. How about just with the green? And the width is always 1.5, and then here's my length that's changing over time. Kind of fun. There's your L. So what did they give us? They gave us, here in green, that the area is increasing. So its rate of change will be positive. Growing. Growing. At a constant rate of 2 square inches. We can write inches squared per day. So if A is my area, they gave us dA dt, the rate at which area changes with respect to time is positive 2 square inches for every 1 day. Or if you prefer, A prime is a positive 2. The unknown, we were asked to find the rate at which this length is changing with respect to time. Rate at which the length so we're asked to find, if L is my length, dl dt, length in inches, time in days, or if you prefer, go find L prime. And we're asked to do this at a specific moment when the moss is 5 inches long. So when L is 5 inches. And again, it's worth noting, since the area is increasing over time and the width is constant, the length has to be getting bigger and bigger too. It's increasing. So I'm expecting dl dt or L prime to be positive. Right? Greater than 0. And now it's time to go ahead and relate our variables. I've been given information about the width. It's always 1.5 centimeters, or sorry, 1.5 inches. I've been asked to find something out about the rate at which L changes with respect to time, and I've been given information about the rate at which A changes with respect to time. So how are length, width, and area of a rectangle all related? We know that the area of a rectangle is equal to its length times its width. And because I know that we discussed this common mistake of substituting in a numerical information too soon, but the mistake is putting in numerical information for quantities that are changing with respect to time before we take the derivative with respect to time. Because my width is always constant, we have that my area is my length times a 1.5. If we prefer working with fractions, my area is 3/2 times my length. Okay, and now all we need to do is to differentiate both sides with respect to time. The derivative of A is 1, chain rule, A changes with respect to time, times dA dt. And here I have a constant multiple, 3/2, times the derivative of L is 1, but then chain rule, L is changing with respect to time, times dL dt. Or if you prefer the prime notation, that's perfectly fine. All that's left is for us to substitute in the known information and then solve. All right, so let's go ahead and do that. So we were given that dA dt is 2 square inches per 1 day. My width is that constant 1.5 or 3/2 of an inch, and we've been asked to find dL dt. I think I will leave units off just for solving this little linear problem, and then we can talk about them in a second. 2 is equal to 3/2 times the thing I'm looking for. Divide both sides by 3/2. In other words, multiply both sides by 2/3, and we get dl dt is equal to 4/3. And these will be in inches per day. And that should make sense. I've got square inches per day divided by inches. Square inches divided by inches is just inches. I've got inches per day. Now, one thing that's interesting about this problem is that because L, the relationship between L and A ended up being linear, that rate of change was constant when we plugged that information in. And so we actually did not even need to plug in that 5 for the inches. This equation, said another way, this equation doesn't have just a L term or factor in it at all. So that's kind of interesting. We did not need to plug in that L being a constant, or find it at what moment in time, because it turns out this is happening in all moments in time, not just when the moss is 5 inches long. We didn't need that. Okay, and I just want to make a note about product rule, because if you didn't plug in that constant for W, and again, it was fine to do that because the width was never changing over time, but if we didn't do that, we would take the derivative using product rule. Let's explore. So if my area is my length times my width, differentiating both sides with respect to time, the derivative of A is 1. Chain rule, A changes with respect to time. Multiply by A prime, or dA dt, if you prefer. And then here we need our product rule. My first function is L times the derivative of second. The derivative of W is dW dt, plus my second function, W, times the derivative of my first, dL dt. Or if you were using the prime notation, A prime is equal to L times W prime plus W times L prime. And now if we plug in the given information, we were given that this is my 2 inches per day. We were given that L is 5. We were asked to find L prime, dL dt, at a particular moment in time when L was 5. What is W prime? We have to investigate this. W is always 1.5 inches, and then L prime is what we're looking for, right? Well, if W is always 1.5, then what must be true? Then W prime, the derivative of 1.5, is 0. The derivative of a constant is 0. So this ends up being 0, which is why that information, find the rate at which the length changes with respect to time, when the length is specifically 5 inches long, that didn't end up mattering. And here we are solving the same equation, 2 is equal to 1.5 times the thing I'm looking for, dl dt times L prime. Excellent.